Hello, this is Mr. Stansbury. I'm going to take you through the 10B Part 1 assignment. All right, so we'll start here with number 2. Find the two decimal places, the unknown length in each of these here. So here, like what I like to do is I like to start with the angle that I have, and then what sides do we know and do we want to know from that angle. So from this angle, this is the opposite side, and this is the hypotenuse. So from our dear friend SOHCAHTOA, right, we've got opposite and hypotenuse, so that's sine. So I'm going to want to do sine of the angle 68 gives me opposite, which is x over hypotenuse, which is 19. Okay, so sine 68 equals x over 19. I want to get x by itself, so I'm going to multiply both sides by 19. And that's going to give me x equals 19 times sine of 68. So just bring out my calculator, and I'm just going to do 19 sine of 68. And we should get 17 point, let's see, to two decimal places, 17.62. Right, so we get x equals 17.62 centimeters for that first one. Okay, let's move on to C here. Here's our angle. From that angle, this is the opposite, and this is the adjacent. So opposite and adjacent is tangent. So I'm going to want to do tangent of 54 equals opposite, which is x, over adjacent, which is 4.82. So again, I'll multiply both sides by 4.82. And that's going to tell me what x is. Okay, so I'll do 4.82 tangent of 54. I get 6.63. 63 meters in this case. And if you happen to be getting answers that are pretty different from this, you just want to make sure that your calculator is in degrees mode and not in radians mode. That's going to mess up your answers. Okay. E, here's our angle. This is across from the angle, so that's the opposite. This is right next to, so that has to be the adjacent, because this here is the hypotenuse. So the one with opposite and adjacent is, again, tangent. So we'll do tangent of 31 equals opposite, which is 8.67 over adjacent, which is x. Now, this is a little different from these because these here we just multiplied by this number, the number that's on the bottom, but in this case it's the x. So really what we're doing is we're going to multiply both sides by x, and we'll get x tangent 31 equals 8.67, and then I'm going to want to divide both sides by tangent 31. Right? So then we'll get that x equals 8.67 divided by tangent 31. Or the easy way to do this is I always just know that if my x ends up in the denominator, then I'm just going to end up switching these two things here. So my x is going to go here, and my tangent 31 is going to go here. So look, it's x equals 8.67 over tan 31. All right, oops. So let's get that excuse me, calculator back out there, and away we go. So we get 8.67 divided by tangent of 31, 14.43, and that's meters. Okay, moving on to G. There's our angle. This side here is opposite, and this is the hypotenuse. So opposite and hypotenuse is sine. So we'll do sine of 28 equals x over 52.4. So since our number's in the denominator, just multiply both sides by 52.4. And we are in business. So let's see, let's get that out here. We got 52.4 sine of 28 gives us 246 Oh, I did 524. I'm like, 246 is way too big for that. So let's try that again. So 52.4 sine 28 gives us 24.60. That sounds a lot better. 24.60 meters is what x is. Okay, and really, as you're going, you really want to double check to make sure that these answers make sense. 17.62, the hypotenuse is 19, that's the longest side, so that looks reasonable. 4.82, this should be bigger than that, that looks reasonable. 8.67, and this is 14.43, that sounds like that's in a good range. This is 52.4, that's definitely longer than this, that's 24.6. Excuse me, that looks pretty good. All right, so let's try I here. Here's our angle. Across from that is the opposite, and this is the adjacent because that's the hypotenuse. So opposite and adjacent is tangent. So let's do tangent 34 equals opposite over adjacent is x over 11. So multiply both sides by 11 and we are in business. So we got 11 tangent 34 here. 11 tan 34 gives us 0. Oops, I did 1 tan. I got to be careful. 11 tangent 34. That looks better. 7.42 if we round it off. So x equals 7.42 millimeters for that one there. And again, that looks like that's a reasonable answer. All right? Okay. Moving on. Number 3, find in one decimal place all the unknown angles and sides of this here. So we want to figure out that other angle and then these other two sides here. So let's just, from this angle, because we know for sure that's 28, let's figure out what these are. This is the hypotenuse, this is the adjacent, and this is the opposite. Okay? So let's do this. Let's find the angle first. We know that all three of these angles always have to add up to 180. That's already 90 degrees, so I know that these two have to add up to 90. So if we do 90 minus 28, that gives us, what, 62 degrees. So theta is 62 degrees. That's this one here. And then now we can work on finding the sides. So let's say, let's find A. So if we're talking about A, we know the hypotenuse and we're looking for the adjacent. So again, SOHCAHTOA. We have adjacent and hypotenuse, so that's cosine. So we'd want to do cosine of 28 equals adjacent is A over hypotenuse is 14.2. So since the number's on the bottom, we can multiply both sides by 14.2. All right. And so let's see, we got 14.2 cosine of 28. Gives us 12.54 if we round it off. Oh, it says to one decimal place, so we'll do 12.5. So A equals 12.5 centimeters. And then to find B, that is opposite and hypotenuse. So that's opposite and hypotenuse, so that's going to be sine. So we do sine 28 is opposite, which is B, over hypotenuse, which is 14.2. So multiply both sides by 14.2. Right, and we get B is going to be 14.2 times sine of 28. Okay, 6.6, so we'll go with 6.7. What is it, centimeters is B. Okay, so we found all of the missing pieces. We found the angle and the two sides. All right. All right, let's move on to the next one. Find to one decimal place the measure of the angle marked theta in these here. So, similar idea with the other ones. We'll just want to find out what two sides we have. So here's our angle. So this is the opposite, and this is the adjacent, because that is the hypotenuse, right? So using SOHCAHTOA, ooh, there we go. So using SOHCAHTOA, we have the opposite and the adjacent. So opposite and adjacent is tangent. So we're going to want to do tangent of theta equals 5 over 4. Okay, so whenever you are looking for an angle, I can't stress this enough. Whenever you're looking for an angle, we want to do second tangent, which is tangent to the negative first. It's the inverse tangent. So if you know what the two sides are to find the angle, you do second tangent, and we just do 5 divided by 4, and push enter, and we get 51 point. It says to 1 decimal place, so 51.3 degrees. So theta, 51.3 degrees. And since that side is a little bit longer than this side, you would expect this angle to be a little bit more than 45 degrees, which it is. So that's a good answer that we've got there. All right. C, here's our angle. This is the hypotenuse. This is the adjacent. So the one that deals with adjacent and hypotenuse is cosine. So let's do cosine theta equals adjacent, which is 3.7 over hypotenuse, which is 4.8. Okay, so second cosine of 3.7 divided by 4.8 gives us 39.6 degrees. Okay, and again, that looks like that's fairly reasonable. All right, so then we can move on to E. All right, so here's our angle. This is the opposite side. This is the adjacent, because that's the hypotenuse. So this is adjacent. So adjacent and opposite is tangent. So tangent theta is opposite over adjacent. So we've got 2.1 over 3.1. All right. So let's do second tangent, 2.1 divided by 3.1. And that gives us 34.1 degrees. Okay. All right, G. Here's our angle. This is the hypotenuse. This is the adjacent. So for this one here, we're going to want to do hypotenuse and adjacent is cosine. So we would do cosine theta equals adjacent is 4.1, hypotenuse is 5.2. Okay, so let's do second cosine of 4.1 divided by 5.2 gives us 37.95, so that would really round off to 38.0 degrees. Okay, and last one on this one here, we've got this is opposite, this is hypotenuse, so opposite and hypotenuse is sine, so we would want to do sine theta equals opposite, which is 7.5 over hypotenuse, which is 12.4. Okay, so second sine of 7.5 divided by 12.4 gives us 37.2 degrees. Okay. All right, moving on to the last one for this assignment here. Find to 1 decimal place all the unknown sides and angles of the following. So we don't have any angles, but we do have a couple of sides here. So honestly, like really the best way to find this last side here is, since it's a right triangle, we know that we can do a squared plus b squared equals c squared, right? So let's do a squared plus b squared equals c squared. We know the important part is that we know that the hypotenuse is the c, so there's our 8 squared. Let's call x, we'll take our a squared, and then b is 5 squared. So x squared plus 25 equals 64. So we subtract 25. X squared equals 64 minus 25. So that's going to be 9. Let's see, 39. Is that what we get? Okay, so then we would square root both sides to get x equals plus or minus whatever the square root of 39 is. So we'll do square root 39. We get 6 point, let's see, to one decimal place. So we'll go 6.2. 6.2. Okay, so officially it's plus or minus, but since we know it's an actual distance, we know that x equals 6.2 centimeters. It's not going to be negative because it's a distance. Okay, so that's how we find the last side. Now to find the angles, let's find theta first. Doesn't matter which one we do. So theta, the two sides that we know are, this is the opposite and this is the hypotenuse, right? So if we're looking for theta, we're going to do opposite and hypotenuse. So opposite and hypotenuse is sine. So let's do sine theta equals 5 over 8. Okay. You could officially use 6.2 in here. So you could actually find this using a different trig ratio, but this 6.2 is rounded and this 5 and 8 is considered to be 100% accurate. So you always want to use these. You could get close with this, but you won't be as close as what you'd probably want to be. So always try to use the sides that they give you if you can do that. Okay, so we're looking for an angle, so we'll do second sine of 5 divided by 8, and that gives us 38.7. Okay, so that gives us 38.7 degrees for this one here. So we know that these two have to add up to 90. So if we just do, so there's theta. So I think that's phi. So what we'd want to do is just do 90 minus 38.7. And that's, oops, not theta, but that's going to give us what that phi equals. Okay, so let's do 90 minus 38.7, and that gives us 51.3 degrees. Okay? All right, let's do B. So we've got A, B, and C for our A squared plus B squared equals C squared. So we've got A squared plus B squared equals C squared. So we got 3.5 squared plus 6.1 squared equals C squared. So let's see what we get for that there. 3.5 squared plus 6.1 squared gives us 49.46. So then we square root our answer. And we get 7.03, and it's just a one decimal place, so C is going to equal 7.0 meters. Okay, so really that's not C, but X. Let's call that X, because that's what it is up here, right? And then now to find the angles, let's say if we're looking for alpha here, which looks like kind of like that. These sides here, let's get rid of the A, B, and the C. So this side here is the opposite, and this side here is the adjacent from alpha here. So opposite and adjacent is going to be tangent. So let's do this. Tangent of alpha is going to equal 6.1 over 3.5, right? Because it's opposite over adjacent. So let's bring our calculator up here, and we do second tangent of 6.1 divided by 3.5, and we get 60.2 degrees. 60.2 degrees for alpha. And then beta here is going to be 90 minus 60.2 degrees, right? So if we do that, we get 39.8 degrees is what beta equals. Okay? That should be all that we need for this one. If you have any further questions, please feel free to ask in class. All right? Thanks. Let me back up for a second. 29.8. Okay? All right.